Hello, ladies and gentlemen. Today I'm going to show you my QO100 geostationary satellite setup in my shack. I have built it so that I don't need a computer to operate it. And yeah, let's begin. On the roof I've mounted a 1.2 meter offset TV dish. The feed I'm using is a dual patch feed with a OCXO stabilized LMB mounted on the back, and from there it goes over about, I don't know, 20 meters normal satellite cable. For receiving I use the AMSAT receive mixer. It is frequency controlled via a rubidium standard, which I will talk about later. The signal goes from 739 megahertz to 144 megahertz. From there it goes into the ICOM IC 9700 radio. This is a dual band radio for UHF and VHF communication. It goes directly into the 2 meter band of it, and this is the receive side. And for transmitting, the signal goes from the 70 centimeter band into an SG Labs transverter. This unit converts the signal into the 2.4 gigahertz band. From there it goes over some attenuators to don't overdrive the power amplifier, and from there it goes into also an SG Labs power amplifier. I've mounted it on a heatsink and also put a fan on it so that everything stays cool. From the power amplifier the signal goes again over about 1 meter thin coax cable into a normal coax cable onto the roof. I guess it's airborne 10, if I'm guessing correct. And from there it goes into the dual patch feed. Everything here is stabilized via a rubidium frequency standard. I bought this unit quite cheap from eBay years ago. I have, with the help from a German ham radio operator, I've modified the 1.2 volt peak-to-peak sine signal into a 3.3 volt peak-to-peak square signal. The frequency it puts out is 10 megahertz, and everything here that is frequency relevant is connected to the rubidium standard. So the radio, the receive mixer and the transverter are all three connected to the rubidium standard, and so there is not a lot of drift and everything is frequency compensated. Here I have only DC voltage regulator to get from the 12 volts I'm using in the shack to the 28 volts the power amplifier wants. And that's basically the whole setup I have here. The radio can be put into satellite mode like I already did, so both the receive and the transmit frequency will be changed. I have a little bit of a receive compensation. I don't know the word. I think it's receive something. This is because the only part that is not referenced with the rubidium standard is the LMB. The LMB has, as I said, a OCXO installed because I didn't want to put another cable on the roof. So I have a little bit of offset, but this is only needed to be set once. If this is set, everything should work. And as you can see, when I change the frequency, the receive and the transmit frequency are changing. I have the signals here in the waterfall, and it looks very great and it's very nice to use. The reason I made such a setup was that I didn't want to need a PC to run everything. I've made tests with several SDR radios, and I also have a Pluto SDR in use on my mobile station that I will show you some other time. Yes, that's basically the setup I'm using. I didn't have the chance to make some contacts in a while, but I hope I can change that soon. Yes, I'm thinking of making some videos in the future about how to set up a QO100 station. I want to make it from the beginning till the end so that I can explain every step needed, like building the feed for the antenna and setting up everything. For that video I think I'm going to use SDR because it's the cheapest and easiest way to get started. And yeah, I hope I can do so the next time so that I can show you something that's actually useful for you. Thank you for your time, and I wish you a nice evening or day, however.